In this video, I'll be working through the question you see on the screen here from the 2025 Leaving Cert Higher Level Maths Paper 2. I'm going to try and show you how to do this question and not just the solution. So definitely pause and rewatch certain parts of the video if you need to. If you're looking for a different question from this paper or a different paper entirely, you should be able to find a playlist in the description below or have a look around on my channel. Okay, let's get into the maths. In question 10, the story they tell us is about a maths test they give to everyone in the world, or all around the world students take this test, and the scores for the whole world are a mean score of 400 and a standard deviation of 60. And they give us the information in this graph and ask us to fill more in. We have the area, they shaded a region here in the middle, and they tell us that's 68%. We should remember that number. That's the number where one standard deviation is important. For two standard deviations, it's around 95%, and for three, it's 99.7%. So they're important numbers to remember. So yeah, what can we fill in here? They told us the mean. The mean is right in the middle, the very middle one. That's 400. They told us the standard deviation is 60. This line here, the lines that hold in the 68%, they're one standard deviation away. One away from 40, or one standard deviation away. So that's 60 away from 400, I should have said, is 460. And 60 away this way is 340. And what's this last number here? They don't actually say. I would argue, if I was arguing with the examiner, I'd be like, impossible to answer this. But clearly what they meant here is this is the second standard deviation. And they never told us it's symmetrical, but it's clear what they mean, I guess. But I'd be a stickler and say you never actually told us this. But that's two standard deviation away. So another 60, that'd be 280. That'd be the answer to part 1. In part 2, they want us to use the normal distribution. They want us to use the table of numbers in your formula book to work out the proportion of students worldwide who would score above 420 on a test. I'm convinced whoever sets the exam for the Leaving Cert is a teenage boy, because the amount of times the number 420 and 69 comes up is way above what it should be. So I'm convinced there's something going on there. Okay, how do you answer this question? I'll draw this again, in fact. I'll draw it loads of times at this time. Normal distribution. We can work out the probability of someone getting over a certain number by the tables in the back here. No, it's not that. Let's find it here. One of these looks like this sort of tables. Lots of numbers. If you put in the number it gives you, this center number 0, it's 400 here. One standard deviation is 1, two standard deviations is 2, and so on. If you put in the number like 1.4 or something, it will tell you the probability that your number is to the left of that. The formula is the numbers they've worked out in the book is everything to the left of that. So for 420, here's 420 here. If we can line that up with its Z score, the book will give you everyone to the left of that, everyone less than that number. Yeah, let me go ahead and shade that in. Every number down here. We would like this number bigger than it. We'll deal with that in a moment. First, let's find its Z score. What's this number here? I know it's 420 up here. What is it down here? It's not as hard as it looks. 60 is one standard deviation. 1 is the same as 60. So what's 20? Because 420 is 20 away from the middle. So what's 20? Well, it's the same as 1 over 3, I guess. Divide that by 3, divide that by 3. Or rewrite that as 0.33333. Two decimal places is all the book can handle. So 33 is fine. That's your Z score. That's what this number here is, 0.33. We can look that up in our book. Am I on the right page? I am. You go to 0.3, go over to 3, and I would get a P number of, so that's P of 0.33 is equal to 0.6293. Be careful, don't leave that as your final answer. That's the probability someone got less than 420. We want the probability they got more than 120, so we'll get 1 minus p of this, and just take 1 away from that. Let me check my notes. We have 0.3707. That is the probability. Also be careful, did they ask for probability, which did they? Yeah, I think they did. Or did they ask for percentage? So multiply by 100 for percentage, 37%. But I believe they asked for probability. So I better round it off then. 0.37. If you are finding my videos useful and would like to help the channel out, on top of liking and subscribing, probably the best thing you could do is to tell other people doing the exam about my channel. Maybe you could share this video in a class WhatsApp group. Then if you feel I've really deserved it and you would like to buy me a coffee, you could become a member on YouTube or on Patreon. You should find links to that in the description below. Okay, on to part B. We still have the same test going on. Worldwide, the average score is 400. But we have 3 different countries here, X, Y and Z, and they each get different scores, at least in a small sample size. Well, a pretty big sample size. Anything bigger than 1,000 I think is pretty big. And they're going to ask us a bunch of questions about these samples and their confidence levels, and they're going to ask hypotheses, things like that. Just a warning, this is one of my least favourite parts of maths because it takes so much studying. You guys need to study for these parts. It's not something you can just go, oh, I'm really good at maths, I can do this. I'm really good at maths. I have to look up these things because there are certain specific formulas there. You have to learn what certain things mean. Just be careful when you're doing all this. Take your time. But do remember, you are rewarded for study. Just work hard on this. It doesn't matter how good or bad you are at maths. This, you can just learn what a lot of these things mean and how to do them. Okay, with that said, the first question is, use the values from this to construct a 95% confidence interval for the population mean score for the country X. Okay, so what are they talking about? So country X, when they asked 2,161 people to do the test, they got a score of 387. So you'd be tempted to say, well, that's the answer then, it's 387. But no, there's a better way to do it than that, because how confident are we in this? We want to add it. We are going to take this number. So let me just get my symbols correct. So the answer we're looking for the mean of this country, I'm going to put it down as this. But this answer, it's tempting to say it's 387, but I'm going to put 387 either side. But really, the real answer is actually a little smaller than that, or a little bigger than that. It's plus or minus something onto this. Let me just move this over here, 387. So that's a good starting number, but let's add a bit of confidence onto it and take it away from it. Because we didn't ask everyone in the country, we just asked 2,181 people. Now what we add on and take away from this side, add on to this side, is something we study, we remember. When they say 95% confidence, you're expected to remember 1.96. You don't actually have to remember it, but we don't bother teaching it. You can look it up in here. If you look up 1.96, you'll find 97.975, which is 2.5%. And remember how the standard deviation works. And if it's 2.5% this side, it's 2.5% this side. And that adds up to 5%. That's where that 5% or 95% confidence and 1.96 comes from. But it's okay just to remember it for now. So that's minus this side plus this side. But it's not just 1.96. We then multiply that by the score we got. The standard deviation score we got here. 66.2. Same on this side, 66.2. And then we divide it by the population. The bigger this number, the smaller this difference will make. So we divide it by the square root of 2,161. Square root 2,161. If you don't care about the maths really, you just have to remember that. And you will see this question. When you see 95% confidence interval, you remember 1.96 the standard deviation they gave us, the population they gave us. They might change the question, so maybe this number is missing, but the answer is there, and so on. But this will come up. Just study it, remember it, you're done. Okay, you just go ahead and put all this into a calculator. We'll clean it all up, and let's see, we get 384.2, and it's bigger than that number, and it's less than 389.8. That's mu in the middle. So I don't know what this country's average score is, but I'm 95% confident it's between these two numbers. So the worldwide score is 400. So I would be confident to say this country's below average. It's not performing up to the standard of the rest of the world. But anyway, that's a 95% confidence interval. Now part C is somewhat similar. It gets very different, but I feel it's a similar way of saying the same thing. In part C, we're talking about countrywide this time. And this time we're going to do a hypotenuse test, a hypothesis test. And the test is that the country has a mean score of 400. So our sample here found 403. But they're saying, well, maybe it should have been 400. If we had asked more people, we would have got the number 400. So that's the hypothesis. And so what do? We do a alternate hypothesis, a null hypothesis, all that good stuff. And what they're asking us to use the values to work out a test statistic, a Z score for that assumption. So we're going to assume 400 is the right answer, and we're going to test it. So we're going to find a whole new normal distribution, and the 5% level of significance is if we find out this test is bigger than 5%, we're going to go, yeah, it could be true. If it's less than 5%, we're going to say, I don't think it's true. Certainly up to a level of 5%. Okay, how do we do that? We have a formula for it, as we always do. These formulas are in your book. The problem is they sometimes look a little different and a little off, because this book is for college students as well as Leaving Cert students. So you have to be a little careful with it. So that formula becomes the Z score would be well, let me write it out like this: X, the mean we found in our sample, minus the thing we're testing, the number we're actually going to test. What's the symbol for that? Mu here. And we're going to divide that by the standard deviation we found. So in that case it's 70.6 divided by the square root of the population. So putting all that in, we get, let's see, it's 403 is what the test found. 400 is what we are testing. It's okay if you mix these up, by the way. 400 minus 403, we'll just get a minus answer. That'll work out fine in the end. Divide that by the standard deviation we found was 70.6, and the population, very big population here. The bigger this number, the more confident we are in the test. I'll show you why that comes out in a minute actually. Square root of 2,724. Put all that into a calculator, clean all that up, and we get a Z score of 2.21779. I don't want to skip ahead, but if this number is bigger than 2, we have usually beaten the 5% significance number, because this is a Z score is the standard deviation. Standard deviation of 2 is right around when standard deviation of 2 is a Z score of 2. And they've asked for 5%. 5% is around standard deviation 2. So we're past the line of proven or disproven. We'll see now in a moment. So remember, we're testing with 400 is correct. Let's draw this Z score in here. 2.2 is somewhere all the way down here. What this is telling you is, this Z score, actually they asked us to put in, they asked us to find the probability as well. So we put this Z score in, and let's put a line here. P of 2.22, that's 2 decimal places. The probability of that works out as 0.9868. Sorry, I should rewind a bit. This was the answer to part 1. This was the Z score for part 1. For part 2 then they asked for the probability. This is not the answer yet. Maybe before I finish off this answer, let me talk about the Z score and the probability. What we're finding here is we're testing if 400 could have been the actual answer, and the Z score and the probability we're about to get gives us the number of out here added with the number of out here, and that's how likely what we tested is to be correct. So the probability of this added up, we put in the number, we get 98.68. That's the area to the left of here, all the way down. So we need 1 minus this, 1 minus 0.9868. That's equal 0.0132. That's this area. But then we need to multiply that by 2 to get both of these areas. Oh, this is why minus wouldn't have mattered. If you had got minus and got this area, you're still going to multiply by 2 to get both of them. So multiply this by 2, the real p-score, the p, what do they call it? The p-value is 2 times this. I don't have it, I don't think I have it written down. 0.0264. That's the probability that this was correct, this 400 guess was correct. And that's a 2.6% chance. And the hypothesis test was a 5% one. If this is less than 5, no, I'm not confident. I'm actually confident to say that's not. So I can actually throw this null hypothesis out. Hypothesis out. If it was over 5%, maybe it was 6 or 7%. I'd have to say, I don't think it is, but you need a confidence level of 5%, and I can't give you that. So that'd be a trickier one. Okay, that's the answer to part 2. And sorry, the conclusion would be sort of what I said there. You thrown away the hypothesis of 400, so you find it is different than 400. It's there. I'm quite confident it's not 400. I think there's only a 2.6% chance that their real mean number could be 400. It's possible, but I don't think it's likely, and it doesn't meet the 5. So, some waffle like that is the answer for the conclusion. Okay, for part D, I don't really know how to answer this question, to be honest with you. They talk about country Z having 50% of the students have a pet and 50 don't. Describe how to sample 2,520 people. They talk about to describe how to sample all these people in a stratified random sample. I guess you can answer, just talk about what a stratified sample would be. That'd be if you break this population into those who have pets and those who don't. It would probably be around 50-50, but wouldn't be exactly. It could be 1,500 in one. Oh, sorry, 1,000. Yeah, let's forget that. 1,250 in one, 1,270 in another, maybe. Anyway, you put them into 2 groups and you do tests on both of them. You test the average and the mean and the standard deviation for one, the mean and the standard deviation for the other. Do they overlap? How confident are you in them overlapping? That's how you do a stratified test. I disagree with the next part. They say, why is it probably not useful to do this when looking at their math score? I guess they want, it's just a joke they're telling. It's just they're saying having a pet wouldn't matter to your math score. And they're probably right. But you know what? I'd like to do the test. Maybe we'd find out people who had pets do better at maths. They're happier, they're just happier people, so they do better. Or maybe we find out people who have pets do worse. They're busier, they're out walking their dog, they get sick from they're allergic to their dog and they get sick. Who knows? So I don't agree with, I think that's maybe a stupid question. They just want to talk what a stratified random sample is. Look it up, write whatever you want. And the answer to the second part, I would disagree with even. But be warned, I'm not the best at this area of maths, so take my answer with a pinch of salt. Okay, part E, we're back to actual real maths. I like it. They give us this graph of people. There's some tests, students are given 0 mark, 1 mark, 2 mark, or 3 mark. And 0.19 or 19% of them get 0. P proportion of them get 1, 2 or proportion get 2, and or proportion get 3. We don't know these numbers. They're going to ask us questions about. They ask us about the expected value of a mark. So the first thing they're asking in this question, what is expected value? They're expecting you to know what that is. The expected value is the proportion of people that get it multiplied by the number. So If I add up all the marks everyone gets, add up all the ones, all the zeros, all the twos, and then divide by how many people did the test, I'd get their expected value. Obviously the expected value is probably somewhere between 0 and 3. If everyone, well, I know everyone didn't get 3, so it's definitely less than 3. That's how we find expected value. We can do that a bit more maths ways. EV, expected value, is equal to 0 multiplied by 0.19, which is 0, plus 1 multiplied by P, plus 2 multiplied by 2R, plus 3 multiplied by R. That's the expected value of this situation. You're getting lots of marks for that, by the way. But they don't really ask just that. They ask, find the largest value for the expected value. I'm guessing students were quite confused by this question because while I think it's a good maths question, it leaves you with a lot of thinking. Some things you might not have noticed earlier in the question. They told you P and R are definitely bigger than 0. And the other thing to note is they could only get 0, 1, 2 or 3. So this is everyone. Everyone is here. That means this all adds up to 1. So we could say 1 is equal 0.19 plus P plus 3R. I'm just adding these two together. That gives us an equation we can get in P and R. I rearrange this. Maybe I'll put P on its own equals 1 minus this is 0.81 minus 3R. That's a very handy equation. I can now put this P in here. I could have rearranged this so R equals, by the way. But I can now rewrite the EV here. I'm not really answering the question yet, but I would certainly get marks for everything I'm doing here. I could rewrite this 0, P would become 0.81 minus 3R. This would become 4R, and this would become 3R. Those cancel. So a nice clean equation. The expected value is equal to 0.81 plus 4R. What's the biggest this number could be? That's what they're asking you. R is bigger than 0. So I know the smallest it can be. If R was 0, it'd be 81. What's the biggest it could ever be? So you need to, and I recommend pause and try and think about that. What's the biggest R could become? I'd say the easiest way to think of that is, well, there's only R and P. So if P was 0, R would be the biggest. If P was the smallest, it could be R would be the biggest. So we could just put 0 up. I guess it'd be easier to put it here. No, let's put it here. We rearrange this. We get 3R equals 0.81. R is equal, what's that divide in as 0.29. That's what R is. So the expected value then, EV, the max, let's write max in here, would be 0.81 plus 4 times this, which comes out 1.89. That's the largest the expected value could be. Okay, that's it for question 10 and for the entire paper. If you have any questions about anything in this question or any question, or point out any mistakes I made, anything like that, put it in the comments below. Do me a favour though, put in the timestamp, helps me answer your question. Thanks for watching and have a great day.